Welcome to another Solidworks video for Ivy Tech Community College, and in this video we're going to be putting together the part that you see here, which is a relatively simple part to model, but we're going to model it in a very specific way using what's called design intent, and we're going to make it so that if this part is updated in the future, certain features always hold true about this part, or certain dimensions always act a certain way. So this is actually from the Barnes additional workbook that I have provided for you in Blackboard. So if you go to Blackboard, I've got some additional material in here outside of our textbook, and we're going to be using the Barnes Design Intent Workbook, which you can just open up as a PDF file, and then you can find a page that shows you all the dimensions for this particular part. If you go down, it's on page 10 for my PDF. So this shows you all the particular options for this part. And then it also describes how the part should behave up here. So we're moving past now just making the parts. We're going to try to make them a specific way so that if we have to go back and update them, it's very easy, and it always keeps the part in spec and in proportion in the way that we want it to be. So this design intent is really what makes the difference between someone who can just make a 3D model and someone who can make an intelligent 3D model that saves them time later on and also is easy to update and maintain if you have a whole bunch of different parts in an assembly. So think of this as making a part that's robust and easy to change later on without too much headache. So looking at this part, fairly simple. We have a couple circles that are extruded out to 1.25 inches right here. And then we have two slots or two cutouts in them. So one cutout we can see here is 0.76 tall and 0.38 deep, and it goes all the way through the part right here, which you can see. And then the other one's a little bit trickier. It's actually a rectangular cutout right here, but it sort of shoots across the top of the part and makes kind of a keyway in the top. So they've told us when we model this part that the origin should be at the center of the part. So we're going to try and make it symmetrical in all directions using the origin right here. They've also told us that the outside diameter increases even though the inside diameter remains constant. So in other words, we have a starting OD of 3 inches right here and an ID of 2. So in other words, if I change the OD to something other than 3, this should stay the same at 2, which that's relatively easy to make that happen. Then 4 and 5 can be a little bit trickier. So on 4, it says the 0.76 inch horizontal slot, which is this guy here, remains centered as the OD is increased and the depth remains 0.38. So in other words, as this depth increases, or as this OD increases from something bigger than 3 or smaller than 3, we want this slot to always remain correct, where we don't have to go back and update its sketch. So we need to make this slot in such a way that it will always be in there all the way through the part, always centered, regardless of what this size is. And I'll show you how to make sure that happens. Then our fifth design intent feature that we're going to try and make sure happens is the 0.38 slot feature in the edge, which is this little guy up on the top, remains 1/2 inch from the back edge. So this one they want to make sure always remains a specified distance away from right here. So in this case, if the thickness increases or decreases, we always want this dimension right here to remain 1/2 inch. Okay, so this is sort of our driving dimension. Now, according to what I'm looking at on this print, I see that they're missing a dimension here, which would be the width of this rectangle. Unless I'm overlooking it, I don't see that dimension anywhere. So we're going to assume that this dimension is 1.75. You can see obviously that I've gone ahead and modeled it, and that's why I know that dimension is missing, or I've assumed that it's missing. So we're going to say that that dimension is 1.75 across there, just because it looks close. Okay, so starting out, I'm going to go ahead and close out my part I made here. And I'll make a new file, just a new part file, and hit OK. And we're going to be in inches, so make sure down here that your units are set on inches. And I'm going to jump into a new sketch. So I'm going to do a sketch on the front plane. And remember, we want to keep this thing centered in all directions around the origin. So I'm going to use the origin as my starting point. So I'm going to draw 2 circles. The first one is going to be a diameter of 2, and the other one's going to be a diameter of 3. So I'll just go ahead and draw them both first using the center point of the origin, and then I'll come back and grab my Smart Dimension tool, and I'm going to dimension the inside as 2, and the outside is 3. And make sure you dimension, don't dimension this, because that's not going to give you the design intent you want. So if I come in here and change this to 0.5, yeah, I have the right size right now, but as I change the OD of this, it's also going to affect the ID. So think about the way that you dimension this and what that's going to make your design intent behave like. So in order to accomplish the design intent where they say the OD increases and the ID remains constant, I need to dimension these two separately. So while I would have the correct size right now, it's not going to be easy to update later. So I'm going to actually dimension like most people would, just right here. That way, if I change the OD right here to maybe 5, the ID remains constant. Okay, so I'm going to change that back to 3. So just check and make sure that this behaves the way it's supposed to as you model it. So that's all we really need for this sketch. I'm going to hit finish. And then now we have another design intent thing that we need to watch out for. When I extrude this, when I go to features and extruded boss base, my distance is 1.25 for the thickness, which most people would just come in here and put 1.25 and assume, okay, that's good. But remember, we want to keep this thing symmetric in all directions. So if I look at where my front plane is, if I just go one direction off of my sketch, that's going to cause this to not be symmetric anymore about the front plane. Now I'm symmetric about the top plane and the right plane still, but I lose my symmetry in this direction. So you want to maintain the symmetry or that design intent when you actually extrude this. So I'm going to, instead of doing a blind extrusion, I'm going to do a mid-plane extrusion. So if I switch to mid-plane, now I maintain that symmetry about the front plane and my design intent stays intact. So as I update the thickness of this part, it always stays centered around the origin, just because I chose a different extrusion option here. So I'll go ahead and make sure that's 1.25 and then accept it. Okay, so going back to our drawing, we say the origin is at the center of the part. We've done that so far. The part is symmetrical, so we're okay with that. The outside diameter increases, yet the inside diameter remains constant. We've accomplished that also with the way that we dimensioned our first sketch. And now we have to put in these two slots and make sure that these two still hold true. So these are the trickier design intent features to include. So I'm going to go ahead and start with this slot right here. And what I'm going to do is I'm actually going to sketch on my right plane right here and sketch this rectangle and then cut it out in both directions. So going back to Solidworks, we have a 0.76 by 0.38 cutout. So I'm actually going to sketch that on this plane. So I'm actually sketching in the middle of this thing, and then I'm going to cut it out in both directions. So I'm just going to choose my right plane and go to Sketch using the little pop-up toolbar here. And then I'll hit a Control 8 on the keyboard. But before I do that, before I hit a Control 8, I want to show you a little trick here for cutting out material. So you can see if I do a Control 8 on this right now, I'm actually drawing on the right plane, but I can't see what I'm drawing because the front half of this model is in the way. And it's getting in the way of my sketch, and I can't see what I'm doing. So this is where the section tool starts to become very useful. The section tool will cut this stuff out that's in front of your viewing model, or in front of your viewpoint, so that you can actually see what you're modeling in there. So if I hit that section tool, it will cut back to my sketch plane by default, and I can cut back to other locations also, but by default it's going to cut back to where I'm drawing at. And then I can hit enter, and it's temporarily cut back. Now all of my geometry is still there, it's just hidden, so you haven't really gotten rid of anything. It's just temporarily out of the way. So now if I do a Control 8, now I can get in here and draw and actually see what I'm working on without having that other mass in front of what I'm trying to look at and what I'm trying to sketch. So now I'm going to go to the rectangle tool and just draw out a rectangle right here, kind of where I want that cutout to be. Not worrying about the size yet, just getting it drawn in there. And then I'm also going to go to my line tool and sketch in a center line. And I'm going to make sure that my center line matches up with the origin right here. So I'll just draw it roughly from here to here. Okay, now I'm going to go ahead and before I dimension this, I'm going to make sure that this cutout is symmetric around the center line. So I'm going to click the top line, Control, click the bottom one, Control, and click my center line. And I'm going to set that to have a symmetric property. Now I can go ahead and dimension it. So we know that this dimension is 0.76, so just using my Smart Dimension tool, I can set that to be 0.76. And then again, with the Smart Dimension tool, we know this dimension is supposed to be 0.38. So we have that fully dimensioned, fully constrained, so you can see it changes from blue to black. So this sketch is finished, so I'm going to go ahead and back out of the sketch. And I'll do a control space bar so I can get an isometric view and kind of see what I'm doing. And then I'm actually done working on this sketch, so I want to bring back the other part of my model that I turned off. So if you go up here and just hit your section tool again, it will turn it off and bring back everything that you hid earlier. So now I'm ready to take this and cut it out. But remember, we want to create this so that as the OD of this part increases, that cutout always remains all the way through the part. So the way that you cut this out is going to be important. So I'm going to go to an extruded cut and choose my sketch right here. And by default, it's going to do a blind cutout. Now, a lot of people would actually go to a mid-plane cutout. They would say, well, let me do a mid-plane and I can go in both directions. And I'll just put in 1.5, or I guess 3 as my total, and that'll cut all the way through everything. And that's true. That would work. So if I accept that, you get the right shape right there, like you would expect. But the problem is you haven't put in the right design intent when you do it that way. Because now if I go back and edit my original sketch, so let's say someone has to come back later a month from now and update this part due to a design change. If they edit this sketch to something larger, like maybe, I don't know, 3.75, and they accept that change, now what used to work doesn't work anymore. And instead of fixing this, now they're chasing changes all the way through the model and all the way through an assembly and probably even a drawing page. So this is where design intent becomes important. Think about the way you model it and how you're going to want it to behave in the future. So doing a couple of undos, if I do a Control Z a couple times, going back to this. When I cut this out, if I edit this feature, so if I right click and go to edit feature, I'm going to change the way that I cut this out. Instead of doing a mid-plane extrusion and keying in a size, most people would say, well, let me do a through all. And they would say, well, I'll just cut all the way through it, except it only cuts in one direction. So here you have to use the option that says through all both. So if I pick through all both, it will make sure that it always cuts all the way through all the material in both directions, regardless of the outside diameter of this part. And that's going to guarantee that if someone comes back and changes the OD on this piece, that the cutout always goes all the way through and we don't have that problem that we just saw a couple minutes ago. So I'm going to go through all in both directions and accept that. And now you can test it to make sure that our design intent number 4 works, that it always remains centered and the depth is always 0.38. So the depth always will be a 0.38 because of our sketch, and 0.76 height because of our sketch, but we want to make sure that it cuts all the way through and that it always remains centered. So if I go back in here and edit this sketch again now and change that to the same 3.75, now you can see that it cuts all the way through like it's supposed to, just because we made that one tiny change in the way that we cut it out. So think about the settings you're using and how it's going to affect your model. So let's do an undo and put it back like it's supposed to be. Okay, and then lastly, we're going to add in this little keyway shape in the top, which is just another rectangular cutout. It is 0.38 wide and 0.25 deep, and they didn't tell us the length, so we are going to assume that that is 1.75 because they haven't told us. Okay, so what we're going to do is we're basically going to create a sketch plane across the top of this part and sort of stamp that cutout down inside the part. So in Solidworks, what I'm going to do is go ahead and add in a new sketch plane. So I'm going to go to my Features tab, make sure you're not inside of any other commands, and I'm going to go up here to where it says Reference Geometry. And reference geometry will let me add in other things. So I can add in other planes that I can sketch on. I could add in another axis that I could use for rotating a part. So you have other options here. So I'm going to add in a new plane, and I have to give it some reference locations. So the first thing that I'm going to do is use a reference of my right plane right here. So that's going to become my first reference. Okay, and I'm going to say that I want to be perpendicular to this. Okay, so that's going to basically rotate this new plane that I'm creating in yellow here by 90 degrees. So This is my standard right plane shown in kind of this pink magenta color, and then the new proposed plane that I'm trying to make here that's shown in yellow. So I know I want them to be perpendicular to each other, but I also want to take this plane and move it up so that it hits right at the very top of this part. So I'm going to go to a second reference and just click on the outside of this part somewhere. And you can see that it highlights it and it actually takes that plane and moves it up. So not only is it perpendicular to my right plane, it's also tangent to this outside edge. And that will guarantee that this cutout always stays in the right place regardless of the outside of this increasing in size or decreasing in size, because that sketch plane is always going to be tangent. So if you're thinking about design intent here, if the outside of this part grows to a bigger diameter, this sketch plane will remain perpendicular, but it's also going to ride on the outside of the tangent of this arc, if you want to think of it that way. So it's always going to be tangent to this surface right here, and make sure that your cutout remains in the right location. So we're going to be perpendicular to the right plane, and I just opened up my, my feature tree right here and picked the right plane. Then I went to my second reference and just clicked on the outside of the model like that. And you can get a little preview of where that's going to come through at. So then I can just accept that. And now you'll see I have basically created a new sketch plane right here that's called plane 1. So I still have my regular front, top, and right sketch planes that I always have, but I've created one additional one that's in a new location, which is called plane 1. So plane 1 is always perpendicular to the right plane, and it always is tangent to the outside of my model. So it's kind of a custom work plane that I can do sketching on still, but it's going to behave differently than the standard 3 do. So I'm going to go ahead and do a new sketch, and I'm going to pick plane 1 for my sketching. And if I go to a Control 8, so I'm looking right at the end of this, going back to our problem here, we're going to sketch out a rectangle right here basically, and we're going to cut that down into the model. And we have our dimensions right here. So we know it's going to be 0.25 deep when we actually extrude it or do the extruded cut. And it's 0.38 tall, and they haven't given us a depth dimension or a width dimension, so we're going to say that's 1.75 since they haven't really told us. So going back to SolidWorks, I'm just going to draw a center line in here to start with from top to bottom, and then draw in a rectangle. And I'm going to make the rectangle cut across here maybe. Okay. The next thing that I'm going to do is make this symmetric. So I'm going to click this side, Control, click this one, Control, click my center line, and I'm going to add that symmetric relation right here. And now I'm ready to do some dimensioning. So we know we always want it to be 1/2 inch from the back edge of the part according to our design intent rules. So I'm just going to dimension from there to there and use that as my location dimension. We know this is 0.38, or it's supposed to be, based on the size. And then finally, we need to know the distance from here to here, which I don't see that they've given us on the drawing unless I'm missing something. I'm going to go ahead and assume that's about 1.75. Okay, so there we kind of have the size that we need. So everything looks good there. So we'll go ahead and back out of the sketch. And then we're going to go ahead and just cut it out. So I'm going to go to my features and do an extruded cut. Choose my sketch, and you can see that by default it's going to do a blind in my case at 3 inches, which I do want to do a blind cut, but I only want to go 1/4 inch deep according to my print. So I'm going to change that to 1/4 inch, and then hit the green check mark, and there's my cutout. And it should look pretty similar to what is in the handout that I gave you. Okay, and then by default, these planes that you create from scratch, they're always going to be turned on until you go in and turn them off. So they kind of clutter your drawing up. So I usually go in and turn them off. So if you go in here and just click on plane 1, you can just hit the little sunglasses here to hide it. It's still there, it's still doing its job, and you can always go back and turn it back on just by hitting the sunglasses again. But I like to turn it off because I'm done with it now and it clutters up the model. So there is our finished part. So to finally check one more time if this thing works the way it's supposed to, I'm going to change the depth of the part and see if this notch follows and stays where it's supposed to. and also maybe the OD of the part to see if this stays where it's supposed to. So I'm going to start by changing the OD one more time and see if the top notch stays where it's supposed to. So let's go to edit and change this maybe from 3. Let's change it to 4 this time. And we'll go back and look at our isometric view. That looks good. It stayed where it's supposed to. And then I'll maybe change the depth here to something else. So let's say if I go to edit my feature here, let's say I change it to 3 maybe. And that looks good. It's always ½ an inch from the back. So I'm not certain that this is perfect, as we have a little goof right there, but without knowing exactly their dimensions here, I'm not sure we're going to be able to get that accurate. But there's a little bit of basic design intent philosophy. So this isn't an especially hard part to model, but it kind of gives you an idea of how design intent is supposed to work and how you want to sort of include certain features in your model when you create it. So you can go ahead and set this back the way it was before. So I'll change this back to 3 like it's supposed to be. And then we'll change our depth here back to 1.25 and accept that. And now that's looking better again like it's supposed to. So I think we do have everything correct there. So there you can kind of just play around with stuff and test the design intent and see what happens. And not only do you want to model the part, but you want to model the part with these specific features. So I like this workbook that I've given to you as kind of bonus material, because most textbooks don't get into this. They just follow the process of draw a part, dimension it, extrude it, revolve it, and hey, you're done. But they don't get into the intelligent design part that really is what you would do on a daily basis if you were working as a designer, where you want to make your life as easy as possible, make your parts easy to update, because you're going to have a lot of work that you're doing and you don't have time to go back and remodel every part from scratch. So design intent is what makes your life easier on a daily basis, because you've thought ahead about how these things are going to be used in real life, and it makes them easier to manage from a file standpoint. So that's a little bit about design intent, and also some more practice with some of the things we've been talking about with sketching and relations and extruding, and making cutouts and making new planes. So kind of a little bit of everything there, trying to wrap it all together and give you some more practice at the same time. So that's just one more video. Go through and try it on your own now. If you have any questions, as always, you can email me, jhamilton83@ivtech.edu, or stop by my office, T316 of the Technology Building. So give it a try on your own now. Good luck, and I'll see you in the next video.